Dear students, today we will learn about the electric flux. What is electric flux? Electric flux linked with any surface is defined as the total number of electric field lines passing through a area. It is given by the product of surface area and the component of electric field intensity normal to the area. Hence, in the way of formula, we can represent electric flux phi equals to E ds cos theta or E vector E dot vector ds. In this figure, we are seeing a Gaussian surface, and we can see that if the electric field lines are perpendicular to the surface, normal to the surface, it can pass through the cross-section area. But if the electric field line is parallel to the plane of the surface, then the electric flux through the surface is zero. Electric flux is a scalar quantity. Magnitude of electric flux can be determined, but not the direction. Outward electric flux through a closed surface is taken as positive, and inward electric flux through a closed surface is taken as negative. It means that for positive flux, the charge enclosed is positive charge, but if the direction is inwards, it means the charge enclosed is negative. SI unit of electric flux is Newton meter square per coulomb. Hence, the dimensional formula of electric flux can be derived as ml cube T minus 3 A minus 1. Electric flux through an area element is defined by delta phi equals to E dot delta S. As the dot product gives us cos theta, to calculate the total flux through any given surface, we divide the surface into small area elements, and then we calculate the flux at each element and add them all. Hence, the electric flux through a surface S can be given as summation vector E dot vector delta S. But if we define delta S to be very small, hence delta S tends to zero limit, then summation vector E dot vector delta S can be converted into a closed integral. Hence, it is the closed integration of vector E dot ds. Now, the electric flux depends upon the three factors. First, intensity of electric field lines. If the intensity of electric field line increases, the value of electric flux will also increase. Second, area cross section. If the area cross section increases, then the magnitude of flux will also increase. And the third and the most important, orientation between electric field intensity and area cross section. Here we can see that if the electric field lines are normal to the area cross section, it means the angle between E and area cross section is 0 degree, then the maximum flux will pass through the closed surface. But if the electric field lines and the area cross section are parallel to each other, it means if the angle between them is 90 degree, then no flux will pass out the enclosed surface. We will explain this with the help of an activity. Friends, to understand the relation between the orientation of the cross-section area and the electric field intensity, we will understand this factor using an activity. For this activity, I have taken a CD and a bottle filled with spray bottle with water. Now, we will assume this CD as a Gaussian surface and the hole in the CD is treated as the cross-section area. If I take this spray bottle and keep this area cross-section normal to this, then we can see that the flux which I treat as the flow of water is maximum through this cross-section area. But as I change the orientation of this CD or the area cross-section, we can see when it is parallel to this spray bottle, then no flux or the flow of water can pass through this area cross-section. Hence, if the area cross-section is perpendicular to the electric field lines, then maximum flux pass through it, and if it is parallel to the field, then minimum flux, it means zero flux, will pass through the cross-section area. Now, let us understand about the Gauss law. The total electric flux through any closed surface S in free space is equals to 1 upon epsilon 0 times the total charge enclosed by the surface. Hence, phi equals to closed integral vector E dot ds equals to summation q upon epsilon naught. Here, summation q represents the total enclosed charge. There are some important points regarding Gauss law. Gauss law is true for any closed surface. It does not depend upon the shape or size of the Gaussian surface. It means Gaussian surface can be of any shape or size. The total charge is the sum of all the charges enclosed by the Gaussian surface. It may be located anywhere inside the surface. Gauss law is based on the inverse square dependence on distance, like Coulomb's law. Inside a conductor, whether it is charged or not, the electric field inside the conductor is zero. Now, let us calculate the electric flux using Gauss law. Here we have considered a Gaussian surface as a sphere of radius r, and the charge q is located at the center of this sphere. The flux through an area element delta S can be given as delta phi equals to vector E dot vector delta S. The value of vector E from Coulomb's law can be given as q upon 4 pi epsilon naught r square r cap. By calculating this, since the normal to a sphere at every point is along the radius vector at that point, the area element delta S and r cap have the same direction. Hence, cos theta represents the value cos 0, and the value of cos 0 is 1. So, this can be given as E delta S equals to q upon 4 pi epsilon naught r square delta S. Now, as we know that the total flux through the sphere is obtained by adding up flux through all the different area elements. Hence, this delta S has to be integrated, and the value of the integration of delta S through a spherical Gaussian surface can be given as 4 pi r square. By manipulating all these values, we get the value Q upon epsilon naught. And this is the value which represents the Gauss law that the total flux enclosed by a surface is equals to the total charge upon epsilon naught. Here epsilon naught is the permittivity of the free space.